Okay, this is exam 1 for fall 21. You throw a baseball with a mass of 2.5 kilograms. Turns out that that mass is not really relevant, but what is important is I have an initial speed of 50 meters per second, and then there are several different things that I'm asking. So first of all, I'm going to write down what I know. That V naught is equal to 50 meters per second. That's in the positive y direction. I'm going to draw a little picture right here too. This ball is going up and then coming back down again. I know that the velocity at the top for this ball is 0 meters per second. I also know that the acceleration is minus 10 meters per second squared. I do know, by the way, that the velocity at the bottom over here is equal to minus 10 meters per second, or excuse me, minus 50 meters per second. But I'm probably not going to use that. So let's see. The first thing I want to know is what is the total time that the ball is in the air. So first of all, I can just think about this. If I start here at 50 meters per second and I have an acceleration of minus 10 meters per second squared, that is, for every second, my acceleration is 10 meters per second, or my change in velocity is 10 meters per second. So that means that for every second, I'm going to decrease my speed, since they're opposite, the velocity and the acceleration. I'm going to decrease that speed by 10 meters per second. That means that at the top, I'm going to have a time equal to 5 seconds, because I go from 50 to 40 to 30 to 20 to 10 to 0 in 5 seconds. I can calculate that. I can say that V is equal to V naught plus AT. V is equal to 0. That's V at the top, is equal to 50 meters per second plus negative 10 times t, and that gives me t at the top, which is going to be 5 seconds. However, that is only the time for half the trajectory, so the total time is equal to 2 times t top, and so that's going to be 10 seconds. That's the answer. B, what is the maximum height? Well, since I know the time here, I can also find the y position. Y is equal to v naught t plus 1/2 at squared. This is really the beauty of kinematics, is that if I know the time and the initial condition and the acceleration, then I can predict the position of an object at that point in time. That is predictive nature of science, which is really quite beautiful when you think about it. So here, v naught was 50 meters per second. The time that I want to know the position is at 5 seconds. I know that's the time at the top of the trajectory. 1/2 of minus 10 times 5 seconds squared. This is 250 meters minus 125 meters. That's 125. And that's my answer. C is what is the velocity of the ball at 8 seconds. So again, I can predict that velocity very simply. It's going to be my initial velocity, which is 50 meters per second, plus my acceleration, which is minus 10 times 8 seconds. That's equal to minus 30 meters per second. Or you could have said 30 meters per second in the downward direction. So this at 8 seconds is going to be right about here with a velocity of 30 meters per second in the downward direction, which makes sense because I know that it's going down after 5 seconds, at time 8 seconds. All right, so here, if I want to show the y direction with time, it's going to look like this. You did this in lab, by the way. So where you throw the ball up and it comes back down again. Notice here that the slope of this graph is initially big and positive right here. Then at the top is 0, and then it increases in the negative direction. So the y versus t graph looks like this. By the way, if I'm drawing the v versus t graph, it's going to look like that, but that's not what I asked you to draw. Okay, a truck increases its speed from 20 to 30 meters per second over a distance of 200 meters, and I want to know how long does it take, and then what is the acceleration. So I prepared you for this, that you would have to solve a system of 2 equations with 2 unknowns, and that is what this problem is. Let's just write down what I know first. I know that my v naught is equal to 20 meters per second. V final, or just V, is 30 meters per second. And that the distance that it covers is 200 meters. I'm going to write these two equations, my two kinematics equations, and I'm going to leave off the units here just because it makes it a little easier to write. So first I'm going to write x equals v naught t plus 1/2 at squared, and then v equals v naught plus at. I'm going to put in the values that I know. 200 is equal to 20 times t plus 1/2 at squared. Notice here I have two unknowns in that equation, and I need to know actually what they both are. So I can't solve that equation because it has two unknowns. And then here I have v, that's 30, equals to v naught, that's 20, plus at. I can go ahead and simplify this. 10 is equal to at. So now I need to figure out what is a and what is t. First thing I want to do is figure out what is t. So what I'm going to do, looking at these two equations, is I'm going to solve this one right here. I'm going to solve it for a. A is equal to 10 divided by t. And I'm going to take this, I'm going to plug it in up here for a. So I get 200 equals 20t plus 1/2 of 10 divided by t times t squared. And when I do that, I get an equation that only has t in it. I can simplify this. That's good because I lose that quadratic term. I'm going to write a 5 right there. So I get 200 equals 25t. And that one's fairly simple to solve. T is equal to 8 seconds. And then once I get time, I can plug that time over here to find acceleration. 10 divided by 8, that is 1.25 or 1.3 meters per second squared. So those are my two answers. I am looking for this ability to solve a system of two equations with two unknowns. Consider this position versus time graph. What is the instantaneous velocity at t equal 1.75? That's right here. In order to find that, I need to know what is the slope of this line. I'm going to look at what is my rise and what is my run. My rise is -1. That is 3 minus 4 is -1. That's the final minus the initial. And then here for the time, I'm going to have the final minus the initial, which is 3 minus 1, which is equal to 2. So for A, the instantaneous velocity is the slope of that line, which is delta x over delta t, which is going to be -1 divided by 2, or -1/2 meters per second. And then what is the average velocity of the interval between 3 = 5 and 3 and 5 seconds? So here I'm looking for the average velocity between here and here. That is, I want to know what is the slope of this line. And I'm going to work that in a very similar way. My slope here is -3 over 2. I said 0 minus 3 and 5 minus 3, and I get an average velocity equal to -3/2 meters per second. All right? I'm sure I did that right. Yeah, that's right. Okay. So it looks like this should have been -1.5 meters per second. All right, what is the actual area of a wristwatch dial? Okay, a wristwatch dial has about 2 centimeters in diameter. So if I say pi r squared, that is the area of a circle, that's 3 roughly times the radius, which is 2 squared. That's going to be 3 times 4, or about 12 centimeters squared. So I'm looking at C as the right answer. What is the length of a typical pencil? Typical pencil is usually, about this distance 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, about 10 centimeters. 10 centimeters is 0.1 meters. Which of these equations is dimensionally correct? Okay, so I just put in the units for each of these. X is meters, T is seconds, V is meters per second, and A is meters per second squared. So I'm going to put in the units here, meters, seconds. That every term should equal to meters seconds for this equation. Meters squared, seconds over meters. That cancels, that cancels. Okay, and so far so good. Just leave this out. Plus meters per second squared, seconds cubed. That cancels and leaves one of those. Okay, so good. I want you to notice here that when I put this V, when I wrote V, I didn't write it as meters per second. I wrote it as seconds over meters. That's because it was in the denominator. Okay, let's look at this next one. Actually, this next one is a kinematics equation, so I know it's right. Meters per second, meters per second. Uh, oh, okay, I'm sorry. Let me pause here for just a second. Okay, sorry about that. But on this second one, I have velocity, velocity, acceleration, and time, and those are all meters per second. So this one's correct, this one's correct. Let's look at number 3. I have meters per second for velocity times seconds. So I should have meters in every part of this equation. X is meters, A is meters per second squared, times time squared, which is second squared. So I have meters, meters, meters. So that means that E is the right answer. All right, what are the units of r in this equation? Okay, well, I'm just going to solve this equation for r. I'm going to divide both sides by t. So r is equal to a over tv. A is meters per second squared, 1 over seconds, seconds over meters. This is the equivalent, by the way, of 1 over v. So here I have a cancel, 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 cancel. I'm left with 1 over second squared. How many sig figs does this have? I'm going to start with this part right here. So I have 3.25 plus 45 divided by, that's 1.4, but I keep the lowest number as decimal places, so that's just going to be 1. So this is 3.25 plus 45 divided by 1 is going to be 50. And then when I add these together, I get 53.25, but I keep the lowest number of decimal places, so it's going to be 53. So that means that C is the right answer for that one. Which of these is standard for the second? That's D. Consider the special triangle. This, by the way, is a 30, 60, 90 triangle. It's one, especially you MCAT people, need to memorize. Where the long side is square root of 3 times the length of the shorter leg, which in this case is 1 meter. What is the angle theta? So here to find theta, since I know the adjacent and opposite sides, I would say what is the inverse inverse tan, excuse me, of root opposite over adjacent, root 3 over 1, and you'll find that that's equal to 60 degrees. And then on the next question, it asks, what is the length of the hypotenuse? We could do the square root of root 3 squared plus 1 squared. That's the square root of 4, which is equal to 2. So r is equal to 2. So as I said, this is a 30, 60, 90 triangle. And the hypotenuse is twice the shorter side, and the long side is root 3 times the short side. Soccer ball has a radius of about 4 inches. What is the volume of the ball? So let's first convert 4 inches to centimeters. You could also calculate the volume in inches and then convert that, but it's a little easier doing it this way. So 12 inches, 1 foot. 1 meter is 3.28 feet. And 1 meter is 100 centimeters. So if I do that, 4 divided by 12 divided by 3.28 times 100. I get 10.2 centimeters. And then calculate the volume of that sphere is going to be 4/3 pi 10.2 cubed. I get 4,400. All right. I mean, in millimeters or in a meter, there are 10 millimeters in a centimeter and 100 centimeters in a meter. So there are 1,000, or you could just remember that milli means 10 to the minus 3. Okay, here we have a kinematics question. My V naught is 40 meters per second. Slow down at a rate of 20 meters per second squared. Now here is slowing down, so the acceleration is going to be opposite the velocity. Not necessarily negative, but opposite the velocity, which in this case would be negative. And I want to know what distance does it cover. I know that x is equal to v naught t plus 1/2 at squared, but I don't know t. Oh, I do know the final velocity, which is going to be 0. So here I calculate my time first. So I'm going to do that down here. I say v is equal to v naught plus at. 0 is equal to 40 minus 20 times t, so t is equal to 2 seconds. And then I can take that t and use it to figure out what distance does it cover. What is its position at 2 seconds? So I'm going to come back up here and say that's 40 times 2. That's 1/2 negative 20 times 2 squared. That's 80 plus 40, minus 40, which is going to be 40 meters. Be careful with your signs. Ooh, actually looks like I didn't have 120 as an option here. I might go back and put 120 meters as an option for the number 11. But just beware that if you get your signs wrong, then you're going to get the question wrong, because you have to keep this negative for the acceleration, or it won't come out right. You throw a rock straight up in the air, as in this figure, the dotted line is halfway. Which of these statements is true? The acceleration at point B right here is positive. That's not true. The acceleration is equal to minus 10. The velocity at point C is at its maximum value. That's not true. It's actually at its minimum value. It's at 0. The speed is decreasing at point D. It's actually speeding up at this point, speeding up in the negative direction, but speeding up nonetheless. And it has a constant velocity. And of course, that's not true. It's changing throughout. So E is right. So the scenario of throwing a rock into the air, or it turns into your hands, same situation. Which of these velocity versus time graphs will have a big positive velocity, 0 velocity, big negative velocity? So that's going to be A. Consider this velocity versus time graph. Which of these statements is true? The object has a negative acceleration at point A. Well, look, this is a velocity versus time graph, so the acceleration is given by the slope of this line. That's not true. It has a positive acceleration. The object has an increasing speed at point C. All right, so look, the speed is pretty big right there, but notice that it's pretty small right here. Oh, I'm sorry, excuse me. I'm looking at that the wrong way. I'm thinking position versus time. Whew, be careful with this, okay? Velocity is here. So the speed is 4.5 meters per second. And here the speed is 2 meters per second, right? Between point C and D. So that means that it doesn't have an increasing speed, it has a decreasing speed. The object has 0 acceleration at point B. Yeah, appears to be. The slope of that line is 0, so that is true. The object is traveling its fastest at point B. Yes, because its velocity is at 8 meters per second, and it doesn't get any faster than that. And the object is traveling in the same direction at points D, which is plus 2 meters per second, and E, which is minus 0.5 meters per second. No, not true, because at this point it changes direction. That's what it means when it changes the sign of its velocity, is that the object moves from going upwards to going downwards. So that's not true. So only 3 and 4 here. Consider this velocity versus time graph, which best represents the position versus time graph. So I should be looking at graphs with only a positive slope. And the reason it's positive because I'm on this in quadrant 1, which has a positive y value, a positive slope, a positive, excuse me, the slope is positive, excuse me, the velocity is positive, so the slope is also positive, because remember, the slope equals the velocity. Let me repeat that. The velocity is positive, so the slope must be positive. That gets rid of this one and this one. Both of those have negative slopes. And here I have a small positive velocity, big positive velocity. Small, big. So I should go from a small slope to a big slope. So A is the right answer. Notice this one went from a big slope to a small slope. By the way, so this one would look like this. If I'm looking at V versus T, that would be for this graph. Notice too that this has a negative acceleration. This one has a positive acceleration. All right, A is the right answer. So this velocity versus time graph, what is the acceleration at t equal 25 seconds? So right here, what is the acceleration? I just need to know that slope. So this is a rise of minus 30, a run of 10, minus 30 over 10, minus 3. Calculate the sum of these two vectors. I always like to draw a picture. That always helps me to draw a picture. 12 units at 30 degrees below the negative x-axis, and 8 units along the negative y-axis. This is 30 degrees. Now I want to find the x and y components. 12 cosine of 30 is 10.4, and 12 sine of 30 is 6. By the way, you MCAT folks, you probably want to learn your cosine, sine of 30, 60, 90 for the MCATs. Just memorize them. Put them on a little note card or something. So here, this is going to be 10.4. So it's going to be 6. And then I also have 8. So my new components are 10.4 and 14. I'm only asking you for the magnitude, so that's relatively easy. I just say 10.4 squared plus 14 squared. And that's equal to 17. All right, so A is right. Travel with a velocity of 2 meters per second, 60 degrees. What is the x component? So Vx is 2 cosine theta. Let me write it out in equation form. Which is equal to 1. All right, let's see, this was from a concept test. Given that these two are, this is true, and the magnitudes of those vectors, that this is true, which of these which of these statements has to be true? These have to be perpendicular. So see, if this is my vector A, and this is my vector B, then this is my vector C. The vector sum of these three vectors is like this, but it's also, because of their right triangle, it's also true that their magnitudes add in that way. That's the Pythagorean theorem. Okay, last question. Vector A is 20 degrees from the x-axis, and B is 170 degrees from the x-axis. Let's draw these. Vector A is 20 degrees. That's a pretty shallow angle. And then vector B is just 10 degrees, just like that. Where are the resultants of these? So, okay, it can't be this one, or this one, because those are all in the wrong quadrants. My resultant vectors have to lie in between these two vectors. That could be A, which is right there, or B. depending on the magnitudes of vector A and B. So B is the right answer. All right.